she's gonna
live
ask the questions.
Millions of people watching.
Only 183. It's okay. It'll be fine. Did you hear? 5.0.
Yeah.
Badass. 5.0. Oh,
Are we
pardon
live?
me. I'll do that a lot. I kill a lot of Pepsi. This generates a lot of heat when we're outside like this.
All right, hey guys, welcome back to Buckle Up.
Ice cold Pepsi.
Brian, let's go ahead and do a mic check real quick.
Mic check. Mic check. Nope. No mic.
But we do have Jed joining us today.
So yeah, guys, obviously I'm Brian, not Mike. And this is Jed. A lot of you guys may have talked to Jed. You thought you were talking to a tech. This is not, he's an engineer that wishes he was a tech. And you know, the more he works with us, the closer he's getting to being one, man. And best engineer I've ever worked with. So kudos to you and welcome to
Awesome.
Buckle Up
Quite the intro. Wow.
with
I hope I deliver.
Mike and Brian with no mic.
Real quickly in the chat, can we just get a thumbs up if you guys can hear us?
Can you hear me?
Just
you hear me?
thumbs up, a yes, anything. Brian, Brian says hi.
Hi.
Oh,
Here's to all my Pepsi fans that I still don't have a whole lot of hashtag Pepsi from you guys. So help me out.
all right, why don't we kick it off with our next Buckle Up, which is going to be on August 19th, so be sure to tune in then. And then one more thing quickly, be sure that you guys rate the app in the App Store. It helps us out a lot. We're raising money all the time. And in order for our investors to give us that money, we have to have good reviews in the App Store, a bunch of them. So please go and rate the app, give it 5 stars, give it a review. We hit 5 stars today on the Google Play Store, but the more the better, so keep it coming.
And guys, because this is all about you, us, but you know what we're here for. We're here to help you guys move through and gain knowledge and share information. So feel free, if you have a particular topic that you would like us to cover on one of the Buckle Up with Mike and Brian's, feel free to send that. Jess looks at all that stuff and writes it down and sends it to us. So let us know if there's a specific topic that you would like as well. Our next one's August the 19th. Today is on thermal expansion valves and other metering devices. And I couldn't ask for a better person to be here on my sidekick in Mikey's absence. Don't call him Mikey. I get to do that.
Yeah.
And don't call him Mikey. He gets all kinds of upset. So, Mr. Jed, we've got TXVs, we've got EEVs, we have fixed orifice devices, and what is I know I introduced you as an engineer, which, you know, has a bad name amongst mechanics, but that's all right.
Sure.
I meant it. The easiest guy to work with as an engineer in this trade that I've ever found. But in your experience, talking about the TXVs and the EEVs and the other metering devices, explain a little bit of the difference between an electronic expansion valve and a thermal expansion valve.
Sure. So a thermostatic expansion valve is really just a mechanical device with a few components. You know, namely there's this valve, and it's got a spring inside of it. It's got an orifice. It's got a nozzle that spring opens and closes. It's got a sensing element or a diaphragm. So really you have a few forces. You know, technically 4 forces that are opening and closing that nozzle and feeding refrigerant through that orifice, which is responding to your evaporator coil. But boiling it down, you have a spring force that wants to close the nozzle, and you have a diaphragm that wants to open the nozzle, and you have your evaporator pressure that is also trying to close the nozzle. So between those two forces, as the sensing element gets hotter, gets colder, that pressure goes up and goes down, so that diaphragm pushes up and down, and that's how that TXV responds to changing loads and feeds refrigerant into that coil in order to maintain a constant super heat. So that's probably a engineer's way of explaining
that
things.
is awesome. Yeah. So you see what I'm talking about? This is an engineer that we can actually relate to. So I'm going to break it down a little. I'm going to break it down a little bit lower.
Yep, let's do it.
So on the expansion valve, you have the power element. That is the round on top of the valve that has the little line that goes to the sensing bulb. The sensing bulb is what is strapped to the suction line, typically at 10 o'clock or 2 o'clock, right?
Right.
So you have the sensing bulb, you have the capillary tube that comes back to the power head. The power head has the diaphragm. The diaphragm pushes on pins. The pins therefore go against the spring pressure, opening up the nozzle.
Which opens the opening in the orifice. So you have a nozzle that opens and closes, and that's what.
So you have liquid pressure on one side. So you all know that the discharge pressure or the liquid line pressure is high pressure, high temperature. As the valve responds to what's going on in the coil, and how it does that is it looks at the bulb temperature, which adjusts the diaphragm. It looks at suction pressure, and all of that is overcoming the spring pressure and adding or taking away pressure on the spring, which moves the nozzle, right?
Yeah.
So you have your high pressure, high temperature liquid as the valve opens, forcing that refrigerant through a small opening, nozzle. On the other side going into the evaporator, then you are expanding that refrigerant, and that's where you change temperature from high temperature, high pressure to low temperature, low pressure.
Very good.
Now, we've kind of given them a nutshell on a thermal expansion valve. What's the difference? What we're seeing in this trade, in the industry, we're seeing more electronic expansion valves, even for the residential equipment.
Mm-hmm.
The higher efficiency, multi-speed, multi-stage equipment is actually coming with not only ECM motors, but we're getting these EEV boards
Mm-hmm.
that are operating electronic expansion valves. So what's the difference?
Yeah. So, fundamentally, electronic valve is intended to do the same thing as a TXV to control precise or approximately precise superheat. It just does it in a different way. So there's a few more components to electronic valve. You typically have a driver, which is kind of the brains of the valve. You have the valve itself, probably a power head, which is really just a stepper motor. You have a pressure transducer and a temperature sensor, like a thermistor. So what the electronic valve does is actually measures the pressures and temperatures, not unlike you would do if you have, your gauges and your temperature clamp. Electronic valve kind of does the same thing. It measures the pressure, measures the temperature, calculates what the superheat is based off, a specific refrigerant profile. So it calculates what the superheat is, and based off what the superheat is compared to what the set point is, it either opens the valve, opens the nozzle, same kind of nozzle, in order to feed more refrigerant through and bring the superheat down, or closes the nozzle in order to feed less refrigerant through and bring the superheat up.
Okay. Again, I like it, dude. That's
Translate for you.
Now I'm gonna reduce it down.
All right.
So, what you just said was, they basically do the same damn thing.
Right.
But where the thermal expansion valve had a bulb strapped to suction line. On an electronic expansion valve, we have a thermistor. The thermistor talks to the brain, but it also uses pressure transducer and talks to the brain, right?
Right.
So we look at actual suction pressure and suction temperature, and then the brain, the module, then does the math.
Right.
And tells that expansion valve, the electronic expansion valve's got a stepper motor in it. So it tells it whether it needs to open or close. So the module talks to the stepper motor and sends it a signal, and it's an electronic pulse, so it'll click and open. And if the machine wasn't running, you could actually hear the stepper motor in some cases, but it'll open that up in pulses. It'll send an electronic signal to the motor that's on top of the valve. So what you're normally seeing as the power element, the power head, the bulb, and the tubing has now been replaced with an electronic motor.
Yeah.
We actually just got a question on that topic.
I'll take it.
What is a good indicator to tell a power head is defective?
Well, I think either one of us can answer that one, but to know whether or not the power head is bad, the simplest way I've ever done is to unstrap it from the suction line. A lot of guys use hot water. I don't use hot water. Your body is basically 100 degrees. And if you just take the sensing bulb off of the pipe and hold it in your hand, you should be able to see a pressure difference in the operation. If you don't see any pressure difference in your superheat or actual suction pressure, look for a leak. That tube that goes between the bulb and the power element, the head, if you don't have them separated out, a lot of guys don't do that. They don't separate them out and leave the curls. They'll do rub outs and they'll start bleeding. So you lose that charge in the bulb. So if it doesn't react, and even if you do get it to react, a lot of guys use warm water. So if you dip it in warm water should open the valve up, which means that your superheat's going to drop and your suction pressure is going to come up. Because if you're overfeeding the evap coil, and by putting the sensing bulb in warm water, you should be opening that valve wide open. So your suction pressure should come up, your superheat should drop.
Yeah, I kind of have a similar approach with some caveats, of course, because I'm coming from
That's the engineer guy.
Yeah.
It's all good.
That definitely will work. Your superheat will drop, so you have to be careful not to overfeed and flood back the compressor. Another option could be get a cup of ice water and do the same thing, dip your sensing element. That temperature drop should close your valve and drive your superheat up. So you should see a response to that, just in the other direction. Your superheat's going to go up.
It's a much safer approach.
It's a safer way to do it. Yeah. But you have to have ice water. So as long as you're on a hot roof with ice water.
I have ice.
Yeah.
And I have Pepsi.
We just got a question from Mr. Mike Mabry.
Oh gosh.
Sorry, Mikey. Couldn't get you turned on today.
What is the proper superheat for a unit using a piston? That is his question.
What is a proper superheat for a unit using a piston?
Yes.
Thanks, Mike. You're about to get two different answers.
Mike,
here.
I'm just shocked right now that you're on Instagram.
No, I'm loving it.
You can't teach a dog. No dog nutrition.
He is trainable.
Yeah, he's trainable. Have those dogs is another name.
Oh, and I need to point out that we're all wearing shoes. Thanks, Mike. Mikey, wish you were here. That would be great having the three of us on this one. So now that I've derailed this whole thing.
Charging a piston.
So a piston is calculated.
Yeah, so as a
That's
fixed,
not the word.
fixed metering device.
Fixed metering device.
That's piston, short orifice, capillary tube.
Targets.
You're going to target superheat, and we're going to define that as, a superheat that varies based off load. And so, I don't know, can I mention?
What determines load?
Load is determined by your indoor and outdoor load, namely your dry bulb outdoor temperature. So
Dry bulb outside. So dry bulb means just take a thermometer and read the actual outside air temperature.
Yeah, of that air going into condenser. That's your outdoor ambient temperature. And your indoor load, which is, your return air dry bulb temperature, so the temperature you read, but it also includes humidity. So if you have something like a Bluetooth hydrometer, a field piece or a testable hydrometer, they will typically give you wet bulb temperature. So that's one thing you need to know. Or it can give you dry bulb temperature and humidity. Or worst case, better than nothing, you should know your dry bulb return air temperature. You can kind of take a guess at humidity. It's not the best thing to do, but it's better than nothing. Typically you can be
And
50%.
And if you go into the Blue On app, we have a calculator for target superheat.
I don't think it's released yet, but coming soon.
It's coming.
Next,
Part of it
next-
is
very soon.
we've been pumping this up for months, guys.
And Brian can't keep a secret.
I can't. But it's going to be in there where all you have to do is put in the dry bulb temperature and relative humidity in the space. And you'll know if you have absolutely no clue, put in 50%. If you're in Florida, put in 50%. If you're in Arizona, put in 10. But these sling psychometer thermometers they're a dime a dozen now.
Yeah.
So you can get them that will actually read the dry bulb and wet bulb, and it doesn't cost you an arm and a leg. I mean, you guys know I'm as old as dirt and been in this trade a long time. So to get that instrument, I mean, your arms got tired because they call them slings, which had a sock, right? You get the sock wet and you sat there and spun it. But today they've got electronic versions of the same thing so that you can get your dry bulb and your wet bulb temperatures at the return air.
Yep. And just a few more tricks or tips. Typically inside a space, your wet bulb temperature will probably be between 55 and 65. For the average comfort level of a human. So if you're comfortable walking inside, just know the sniff test is your wet bulb temperature is probably between 55 and 65. If you're outside of that, you're probably going to be uncomfortable. Below 55, you're going to be cold. Above 65, you're going to be uncomfortably warm. Sticky, yeah. The target superheat can range based off conditions from 5 to 40. You never want to go below 5 when you're charging a superheat. You should have it, at least 5 degrees of superheat under all operating conditions to give you just a little bit of factor of safety. And if you you can kind of guesstimate based off your load, your outdoor load, your indoor load, you can kind of get the feel for whether you should be on the low end of that, like 10 degrees, or if you have a really, really high indoor load, you're probably going to be on the top end of that, like 20 or 30. When in doubt, have a little factor of safety in there, go for a little bit higher superheat. You may sacrifice some efficiency and performance, but you're going to protect the system.
Yeah, and you'll see, I mean, for those of you, I know we're talking about TXVs and metering devices, but if you guys are familiar with the app, everything that we do, everything that we teach, point out, it's all protecting that most expensive piece of the equipment. That's the compressor. If you blow up a compressor, that's a big chunk of money. So anything that we do in this trade, the worst thing you can do is damage a compressor. So if you continue to watch that superheat and make sure that you have no liquid coming back, because as I've said, Jed knows, Jed said, compressors are not liquid pumps, they're vapor pumps. So make sure that you're superheating, and that 5 degree mark, that's pretty solid. Nothing below 5 degrees. It's just cheap insurance that you're not going to break or damage a compressor.
Ready for the next question?
Absolutely.
Okay. If you have a unit with 4 stages of cooling and want to enable all of them, would the best way be to bury thermostat at its lowest setting?
Well, yes and no. If you want to bring on all stages, then yes, you need to bury that stat and make sure that the machine fully loads. If you're doing a full load test on a machine, then yes, you need all stages running. There's only 2 performance tests that I am aware of. 50% is not reliable. So you have 0, machine's not running, pretty good baseline there, and 100%. So to get 100% load, if it was 65 degrees in the space and you bury the stat to 40, you're not really going to get a good full load test. You would need to be 75 degrees. You need to be within design. So, for example, our 22 equipment was designed for a 40 degree evaporator and 105 degree condenser. Everybody here, including Jed, knows that in the real world, you are never going to find those conditions. Those conditions are going to last for about a minute. So to say to bury the thermostat, yes, that's how you're going to get it to fully stage up. But if you fully stage it up and it's 70 degrees, that's probably not going to give you your best load test. Probably somewhere between 75 and 80 degree return air and 90 to 100 degrees or 80 to 100 degrees outside air would be your best test for full load on that one.
Yeah, I think I would just, Brian kind of hit on it, but you can run a system under full load as long as you have a decent return air temperature. I think that's typically 70 degrees is what I would probably feel comfortable at. But if you're at 70 degrees when you try to stage on those compressors, you're probably not going to run for very long. So, there's a couple different, of course, caveats there. I wouldn't probably stick the thermostat down below 65 because if you go lower than that, then you start risking the equipment.
Well, there's a difference between setting the thermostat so that it fully loads. And I tell this to a lot of the guys. Yeah, I tell this to a lot of the guys. Look, here's a good rule of thumb. Return air minus 40, that's your coil temp. You have to look at that straight across on your PT chart. But if I'm at 70 degrees, you subtract 40 degrees from 70, what do you got? 30. That's 2 degrees below freezing. So what have you got on the coil? Ice. If you got ice on the coil, you got liquid coming back to the compressor. A potential of. So what is the lowest setting you can have on return air?
You wouldn't run it, I wouldn't run it much below 70. I would agree with that. You have to have enough of it, I guess, deadband between your set point and your space temperature to bring all 4 stages on, but you really never want to run that system much below 70 degrees return air.
And then still, you have to look at the pressure temperature charts because everybody's different. We could get away with a 70 degree set point for R22. You cannot get away with it on 410.
Why do you say that?
You look at the PT charts on them, and you will see that the freeze point, that 32 degrees. So just just know that well, everybody knows setting it for 65 degrees does not give you colder air. So full load tests are totally different. I've gone through a whole lot of chillers, and full load tests is pretty common but we gotta let the building warm up
Yeah,
quite a bit.
I guess that's the way to break it down. In order to do a full load test, you should have a full load on the system. Otherwise, you're risking the equipment.
Yeah.
All right, we have a elaborate question from JR65 HVAC, and he's asking, residential 410A, 130/280, 2.6 superheat, 6 subcool, all dampers open, registers open, variable speed motor operating properly, filters clean, coils clean, blower clean, airflow fantastic. What's up?
What's his delta D?
130/280.
That's pressure. Did he give us the temperature
I guess
differential?
what's the problem? Nothing really scares me out of that, depending on the load.
No, actually, it sounds jacked up.
Maybe
I
with
don't
that
know.
pressure,
What was the supply air? What was the return air?
I don't know. Okay, so 410A, refrigerant.
Yeah.
130/280, don't know what that is. 2.6 superheat, 6 subcool.
So his superheat is low.
Yeah. Subcool
Is-
is 6.
Subcool is low. I don't have a 410 calculator. I'm just looking at your superheat is low.
138 is going to be like probably 50 degrees saturation. Just
Yeah,
to
but what's
get-
his return air? What's his
Right, we don't
supply
have to
air?
load.
What's the outside air temperature?
Comment below. Return temp minus
No.
35,
There ain't no minus 35 on return air. Come on.
20, delta T 20.
Your delta T is 20 with a low superheat, low subcool? No. Your filters are dirty, your coil's dirty, you're not moving enough air.
What type of metering device?
Don't know. Comment below. What type of metering device did you use?
So I mean, you could probably
No, I
turn
did.
the sound down a little bit.
Well, there's something in typical 5-ton and under, it's non-adjustable, we get it.
Take a little product out,
Um,
sacrifice some stuff.
I understand your filters were clean, your coil looked clean, but there's something else going on because your superheat's low and your subcool's low. You're dealing with 2 degrees and 6 degrees. Both of those numbers are low. So what's the outside air temperature? You had a 100 and, can you repeat the suction pressure?
138, something like that.
138. So he's got an 85 degree return air. What's the outside air temperature?
Was it 85? I don't think it was 85.
Again, I don't have a PT chart in my head, but it sounds to me like it's not.
I think he's running under low load. I mean, it's 6 o'clock at night most places, and so yeah, he may be a little bit slightly overcharged for like a fixed metering device, or if it's a TXV, close down the stem a little bit, or take a little product out. But I mean, he's got
Or
good delta T. He's
A
probably
lot of these guys are dealing with also somebody put in a 410 condensing unit and didn't match the indoor piston to the outdoor unit.
Yeah, could be overfeeding, and that
So
would have
it
low
sounds
set-
like it's a little
low
bit
super
because
heat.
if he's got his subcool sounded low 6, that sounds low to me.
Some manufacturers is 8 design, so
So it'd still be low.
plus or minus 20%.
See, this is the engineer fun right here. So his subcool is low, but his superheat is low, which means he's overfeeding the indoor coil.
Mhm.
So it could be the fact that the piston is not matched to the outdoor unit, and his piston is overfeeding, which would give him a low subcool and a low superheat.
Mhm.
So the airflow might be right, the filters are good, the coils are clean. He's getting 20 degrees, but it don't sound right because he's got a low superheat.
Yeah,
All right,
could be a couple things. There's some
a couple of
options.
things you can look at, but can't give you a straight up because you're missing some numbers.
Hey, maybe that's a good point to make. Like, what are all numbers we need to have a complete picture of diagnosing a unit?
Return air, supply air, outside air, suction temperature, discharge temperature, liquid line temperature,
High pressure, low pressure.
high pressure, low pressure.
Yeah, really, I always remember it's kind of 7 things, maybe 9, depending on how you're looking at. Suction pressure, head pressure, suction temp, liquid temp. Discharge is kind of nice to have, but most of the time you don't use it. Sometimes you do. Return air temp, supply air temp, outdoor air temp. And I say return air, supply air, that should include humidity or wet bulb. That's ideal, but that's ideal. So until you have all those things, you don't know what the load should be. You don't know what the load should be doing, or the system should be doing. So
It's funny.
kind of
It's
a guess.
funny how questions read. It's like cautions breed cautions. Questions breed questions.
Brian, Brienne has a question. You ready?
Mm-hmm.
For all you watching, Brienne is Brian's daughter. She's really awesome. And she
Thank
does
you.
have a question. How do I diagnose a bad TXV valve?
We went over the sensing element part.
Yeah.
Wow, daughter.
That's probably the most common, I would say.
That was, and no, not all units use W2. How do I diagnose a
Bad TXV valve.
Can I jump in?
Yes, you may jump in, of course.
Well, we mentioned the sensing element part, so I feel like we covered that. But
So sensing element, yeah.
if you feel good the sensing element's working, kind of what I would probably do is try to adjust the stem and see if it works.
Mike said use the blue on tech support button.
There you go. Yeah. Stem.
Thanks, Mike.
Thanks, Mike.
I would adjust
So
the stem and see if the valve reacts.
But our typical call is a fixed, non-adjustable expansion valve.
Okay.
So you can take the sensing bulb off the pipe, warm it, or as Jed suggested, cool it, and see if your pressures and temperatures change.
Yeah, I feel like the sensing bulb is probably the only thing you can really do there.
Yeah.
Because it's, again, an expansion valve, there's basically a spring and a diaphragm fighting against each other. That spring is typically not going to fail. You may clog your orifice, which you'll see a big restriction there. So that's one thing to check.
That was the piece that I was going to say. Is if you see a normal head pressure, normal to high subcool, and you see a low suction pressure with a high superheat, that is an indication of a restriction. So check your liquid line dryer, do a temperature check across that. If that is normal, normal is less than 1 degree, then you are kind of pointed to the expansion valve. So if the expansion valve is contaminated, and 410 30-year-old R22 machines, they'll foul. The mineral oil has paraffin. Paraffin builds up on the walls of the piping and on the walls of the expansion valve. So a 30-year-old machine to have a restriction, but for whatever reason, on the 410 equipment, and I still haven't been able to put my finger on it, but they gum up. The expansion valves gum up, the stems stick, and I've seen this on 2-year-old pieces of equipment.
That's interesting. I mean, POE will strip paraffin more readily than in mineral oil. So if maybe that system, when it got installed, got a bunch of junk inside of it, and then the POE stripped that junk through.
Maybe.
Possibly.
Yeah, I haven't, I know it's the paraffin.
Oxidation, if you're not flowing nitrogen when you braze, maybe.
Well,
that's that.
yeah, that'll crap up a whole lot of stuff,
Yeah.
but thanks for the question anyway. Half a heart. The other side's got Pepsi in it.
Keep asking your questions. Again, TXV and metering device questions. Ask away. These two guys will help you out.
You want to talk about Accutropes or any of the short orifice metering devices?
We do have that. That would be, yeah, we spend a lot of time on TXVs.
Yeah.
So Accutrol, short orifice, it depends on the manufacturer what they call them. Would you like to take a stab at the definition so that these guys understand that when we say Accutrols or short orifice devices, what we're talking about?
Sure. Yeah. So, you know, my definition of short orifice, and again, it depends on what the manufacturer calls it, is just exactly that. It's a very short orifice. So let's say you have just a tube of piping going into, let's say, an evaporator header. There could be literally just a small orifice to where that pipe goes from full diameter down to a very small orifice, and that's the metering device. Typically there's multiple short orifices on a given evaporator header. So Carrier calls that the Accutrol. I think Train calls it a short orifice specifically, but basically you have just a bunch of small orifices built within the pipe itself, or the connection of your suction line coming into your evap on many different headers up to the evap.
Can I use my Michigan, for my Michigan folks, this is the state of Michigan?
Saginaw, Detroit.
Oh, I got that wrong hand
Peninsula,
up.
UP. Come on.
So I kind of do it a little bit different. So if you look at, this is going to the evaporator, and this is your liquid line coming in. So on the Accutrol, Accuflows, so the liquid line's coming in, and it's feeding into what looks like 3/8 tubing. Just looks like you're going from a 1/2 inch to a 1/2 inch header into 3/8 tubing. You have to look really close right before it goes into the evaporator, and you'll see crimps.
Mm-hmm.
And if you see the crimps, and I know Carrier does it, York does it, Train does it, and that's what we're talking about with the Accutrol or short orifices. And what happens a lot of times is you'll see 8 tubes going into the evaporator off of one liquid line header. And if you're not getting your suction pressure, your head pressure is going to look normal. Your subcool is going to be extremely high. But if you're seeing a low suction and a high superheat, take a temperature reading. And a lot of you guys got temp guns out there, because be careful. You try and reach in there with the fan blades running. Take temperature readings of those that are going into the evaporator, and you will see temp differences on those. And what happens is those orifices, and they're fixed. It's like not like a piston on a 3.5 ton residential where the heat pump, where the piston it meters in one direction and bypasses in the other. These are fixed. They're crimped right into the pipe, and they plug up. And when they do that, of course, your capacity goes down. And they're fun to replace too.
Oh, I'm sure.
We got any more up here?
Yeah, we have a few people asking how to diagnose a bad reversing valve.
Wow. Go ahead, Jed. You want to take a stab at a bad reversing valve?
Oh, yeah, I guess so.
We're gonna test his engineering / technician skills here.
Yeah, I never know a whole bunch of it, but here's what the valve, I typically, again, probably depends on manufacturer, but most often I think in heat pump mode, so when the valve is de-energized, your whatever's plugged is going to be in the heat pump mode, so that, worst case, if the reversing valve fails, it's going to fail to heating mode. You'd rather fail to heating mode when it's freezing outside versus fail in cooling mode when it's freezing outside. So de-energize should be all the way off, and when you give it 24 volts, you should hear the plug clicking on and off. When you hear it click on, you should go into cooling mode. When you disconnect 24 volts, it should go into heating mode. It should be, from my experience, a physical
and most manufacturers are following that bandwagon where it defaults to heat.
Mm-hmm.
But there are still manufacturers out there that you have to energize for heat.
Yeah, I guess bottom
Which
line
is-
is you have a 24 volts, you just hear it click.
which is crazy.
Yeah.
All residential equipment, in my most humbled opinion, all residential equipment should default to heat so that
Yeah.
you don't freeze people out.
Yeah, it's better to die of overheat than die of freezing to death.
Yeah, a person can
Sorry.
fill their bathtub full of cold water and cool down. I'm sorry. But when you get cold, wow, totally different. So, how to check for a bad reversing valve?
Yeah, how to do.
Obviously, you've got your pressures. So if you've got the system running and your suction pressure and your discharge pressure are equal, you could have, if it was a piston and reed compressor, you could have bad valves. Very tough to know the difference between a bad compressor and a bad reversing valve. If you've got a bad scroll compressor, you're going to be looking at your amp draw. If your amp draw is less than half, typically, then you know that the compressor is not functioning. If your amp draw is pretty close to the normal run loaded amps, then yes, look at the reversing valve, and you're going to take temperature differences between the true discharge and the true suction, being those pipes that actually attach to the compressor and the pipes that are leaving, going to the external components. If you have any temperature difference at all, so if you, and I'm just going to use a number, if your suction temperature coming back from the evaporator was 45 degrees and the suction temperature leaving the reversing valve going to the compressor was at 55 degrees, that's a 10-degree difference, which means that the reversing valve is leaking past.
You basically got a bit restriction or.
Well, it's not, it is not, a reversing valve is pretty simple. It's a U-tube that takes and directs the discharge gas either to the outdoor coil or the indoor coil.
Mm-hmm.
So if it's mid-seated, then it's, it's leaking and sending hot gas right to the suction line. So, but again, I go back to, by the way, on a heat pump, if you're replacing a compressor because it failed, automatically change the reversing valve. That is such cheap insurance because it is always behind the compressor.
Isn't it easy to overheat the reversing valve?
Oh yeah, we can do a whole separate class on how to change reversing valves. There's a ton of different ways that guys have done that to not overheat them. Myself, I cut them out and redo the stubs outside the machine, and so it goes back in with couplings.
Yeah, makes sense.
Every one of them that I did, because they're so susceptible to overheating when you braze them back in.
Mm-hmm.
Good point, though. Thank you.
I think we'll start to wrap it up here. We're at 45 minutes in.
Has it been 45 minutes already?
Yeah.
Dude,
Time
Has.
flies when you're having fun.
thank you, man. Man, enjoyed having you here.
Thanks
you, guys.
again to Jed for being here today. Woo!
Told you, best engineer.
I'll
ever.
clap on behalf of all of you watching.
Round of applause.
There should be some caveats and some asterisks to those qualifiers.
No, you don't. You're totally good.
Our next buckle up is August
August
19th. So be here.
Keep
Make sure
your
you
eyes-
have all your notifications on so you can keep up with us every other Thursday at 4 p.m. Pacific time.
So over talking, Jess. It's bad.
What?
I was interrupting you. I'm sorry. I was
It's
apologizing.
okay.
I didn't want to overtalk Jess. It's bad.
I'm just
So,
the announcements.
yeah, August the 19th is our next buckle up. Don't forget to keep your eyes open for the new forum. It's like days away, man. I'm so excited about this stuff.
It's gonna be so cool.
Could be seconds away. Just
Yeah.
You never know. Just keep, make sure you have your app, your Balloon app on automatic updates so you don't miss it. That's huge.
Thank you so much for your app reviews. We so appreciate it. We're all focused on keeping it free for you guys and keeping it free, keeping it real. So thank you very much for your app ratings.
Yep.
Look
Mike,
for us at August 19th. Again, tech support line. We're as soon as the new update comes out, you're gonna have 4 different options instead of 3, but you will still have the 3 manuals, under 20, over 20, adding chillers.
I'll be posting all of the how-tos next week on Instagram, so you'll be able to use these features. And it's actually Jed walking you through these new features, so it's gonna be really cool. Mike, no, I will never be in front of the camera. Never, ever.
No, we're gonna fix that.
No. Absolutely no. Nope. Nice try.
Yes, okay.
Whoa.
All right, guys. Peace. Thank you very much. See
Thanks
you in
for
2
joining.
weeks.
Peace. See you on the 19th.